Hello everyone, hopefully everything is well, and in this video we're going to find dy dt using implicit differentiation. But instead of saying implicit differentiation, it's better to say using related weights because it's not really dy dx. We're not going to derive with respect to x. Instead, we're going to derive with respect to time, to t. But there are two techniques that you can use in this example. But first of all, let's see what they ask us to do. Assume that x and y are both differentiable functions of t, and find the required values of dy dt and dx dt. So first of all, we need to make sure we derive that functions properly. How to derive with respect to t? First of all, you take the derivative. I'm going to change the color so you can see the difference between what you have and what we write, okay? So here, it would give us 2x dx dt, because we derive with respect to t, plus 2y dy dt, because remember, we're doing implicit differentiation. So if you want to see more about implicit differentiation, feel free to look at other videos. So what is the derivative of a constant? It's 0. Now, if we subtract both sides, 2x dx dt, we're going to have 2y dy dt equal negative 2x dx dt. Now, let's divide both sides by 2y. So we end up having 2y dy dt equal, when you divide it by 2, negative 2 divided by 2 give you negative 1. Now we have minus x over y dx over dt. Now, this is the derivative of our functions, which is the equation of a circle. Now, we can answer the two questions they ask us. First of all, they ask us to find dy dt when x equal 5 and y equal 12 times dx dt is 7. So all we need to do is substitute and simplify. So dy dt equal negative 35 over 12. We answer the first questions. The hardest part is really to find the derivative. Usually in this type of functions, we derive with respect to x. If you derive with respect to x, know that you would do 2x plus 2y dy dx, but you would multiply both sides by dx dt, and you would end up having the same thing. Now, we can answer the second questions where they ask us to find dx dt when we know x equal 12, y equal 5, and dy dt equal negative 4. So after doing a couple of steps algebra, we realize from dy dt equal negative x over y dx dt, we can solve for dx dt. That means multiply both sides by negative y over x. It would give you negative y over x dy dt. When we multiply the right hand side by negative y over x, so this one would be equal to 1. So we have only dx dt left. So we're going to use this formula to answer the second question. So what the second question tell us, remember B, we're still doing B. So they ask us to find dx dt equal negative y. Remember, that should be negative y over x dy times dy dt. Let's substitute. Y is 5, so we're going to have negative 5 over 12 times negative 4. So what dx dt give us? That would give us 20 over 12 with a common factor 4. The top one has 4, the bottom one has also a 4. So common factor is 4. 4 times 5 is 20. 4 times 3 is 12, simplified by 4. The final answer would be 5 over 3. And that's how we proceed to find the implicit differentiation. That means dy dt when x equal 5, y equal 12, and to find dx dt when x equal 12, y equal 5, and dy dt equal -4. Hopefully you can use this example to do more related rates functions with implicit that's involved implicit differentiation. Let me know if you have any questions. Don't forget to subscribe for more videos. Take care.